Introducing Suzuki's Advanced Anti-Lock Braking System, or ABS. ABS is a supplementary system designed to provide assistance to the rider's braking operation over various road surface conditions. This video is a 4-part explanation of Suzuki's ABS. Part 1. ABS on paved road surfaces. Part 2. ABS on slippery road surfaces. Part 3. Evolution of ABS in the past decade. Part 4. Operation of ABS. This section describes ABS operation on dry paved roads. The ABS testing vehicle in this video is fitted with outriggers, sled-like devices, and the tires have white tape attached to make it easier to check their rotation. First, an example of an expert braking operation by a professional test rider from 60 kilometers per hour without ABS. The rider precisely controls the brakes and reduces speed in a steadfast manner. However, if the rider applies the brakes too hard, as is expected with riders of average skill level, wheel locking occurs. When wheel locking occurs, the braking distance tends to increase compared to the braking distance with a professional skill level braking operation, and the bike's movement becomes more difficult to control. Next, an ABS-equipped bike. This footage shows the rider applying the brakes hard without being concerned about wheel locking. Let's compare the two. Now, let's take a look from a different angle. First, the professional skill level braking operation without ABS. This time, the rider applies the brakes too hard. Wheel locking occurs. Next, the bike with ABS. The bike slows down without wheel locking up to the moment it comes to a stop. Let's compare. Even when the rider applies the brakes hard, the ABS-equipped bike slows down without wheel locking up to the moment it comes to a stop. This section describes ABS operation on highly slippery surfaces. This is a specially prepared slippery road surface that's made even more slippery by a water truck. Braking from 30 kilometers per hour. Reducing speed without ABS requires much caution in controlling the bike. The rider applies the brakes too hard and wheel locking occurs. Next, the ABS-equipped bike. Even when the brakes are applied hard, it is possible to slow down without locking either wheel, up to the moment the bike comes to a stop. Let's compare the two. Now from a different angle. The rider on the bike without ABS slows down by controlling the brakes very carefully. When the brakes are applied too hard, wheel locking occurs. Next, the ABS-equipped bike. Even when the brakes are applied hard, the bike slows down without wheel locking up to the moment it comes to a stop. Let's compare. As you see, the wheels on the ABS-equipped bike do not lock up to the moment the bike comes to a stop, even when the brakes are applied hard on a slippery road surface. ABS-equipped motorcycles were already in existence from about 10 years ago. This section is a brief explanation of the evolution of ABS over the past decade. Earlier ABS designs had ECU and the hydraulic system as separate units, together weighing about 4 kilograms. The latest design combines them into one unit and weighs only about 1.5 kilograms. The latest lightweight ABS unit, positioned closer to the center of the chassis, contributes to centering the motorcycle's mass. The latest ABS uses active-type wheel speed sensors for a more precise detection of wheel rotation speed from low to high vehicle speeds. ECU microcomputer processing speed has been increased from 8-bit to 16-bit on the latest ABS, making possible more detailed control under various road surface conditions. A braking operation using an earlier ABS design. As you see, the more detailed control of the latest ABS results in a smoother braking operation. This section describes the operation of ABS. ABS automatically regulates brake force in order to prevent the wheels from locking. Central to the ABS design is a set of mechanical systems that precisely detect the rotation speeds of both wheels, compute their difference from vehicle speed, and regulate the brakes accordingly. Vehicle speed estimates used in ABS control are obtained by comparing between wheel speed sensor information of the present moment with that of moments before, and by monitoring the difference in front and rear wheel rotation speeds. The wheel speed sensors each monitor rotation speed about 100 times every second. Let's look at the basic sequence of ABS operation. As the rider applies the brakes, hydraulic pressure increases, producing the braking force. When the speed of either wheel is detected to be slower than the vehicle speed to cause wheel locking, the ABS decreases the hydraulic pressure to reduce the braking force. When the wheel speed once again approaches the vehicle speed, the system, judging that wheel locking has been avoided, returns the hydraulic pressure back to the same level. ABS, within the limits of its operational range, helps prevent wheel locking caused by braking operation and helps to enhance the bike's braking performance. ABS assists braking operation on a wide range of road surface conditions. High-quality ABS delivered with Suzuki's high technology.